Simpson. So Phil, it's wonderful to have you here. Phil is the Senior Principal Product Marketing Manager at Red Hat. He is a Red Hat now is part of IBM, and he's responsible for the go-to market strategy and positioning for Red Hat. Red Hat's business process management and decision management products. Phil brings more than 20 years of experience working with BPM technology and is excited to have this opportunity to share his perspectives today with the IBPM audience. And Phil, we're really honored to have you here, such a great industry leader sharing this experience firsthand with us, and really look forward to your presentation. Phil, I don't have your audio right now. Just make sure that you are unmuted. Oh, let me unmute you here. Yeah, you're self-muted right now, Phil.
There we go.
There you go. You got it. You got it. Technology hurdle number one overcome.
Awesome. Thank you so much. All right. So let me share my screen here. Thank you very much, Jose, for that introduction. Hello, everyone. Welcome to the session this morning. I'm delighted to be able to speak to you today. So the topic of my session is BPM Reimagined, the impact of emerging technology on business automation. So we're going to take a technological journey, looking back at BPM as it originally started out, and then what are the really interesting new emerging technologies that are coming in and starting to impact the way that the BPM is used in practice. So let's get started. I thought what I'd start off with is just a quick refresher on BPM as it started out, or at least as it began to mature. I found this diagram on Wikipedia. It was published in 2007, and it's an illustration of the main components of a business process management system. And it's not vendor specific, so this isn't about any particular vendor's product, but essentially this was trying to lay out, what are the key components in BPM, what should you expect to get if you purchase and deploy a BPM system. So you can see in the middle of this diagram here, we've got the green box labeled BPM Suite. And it's divided really into two parts. There's the box on the left is titled Workflow Application Services. This is what I would call the runtime components of the BPM system. So this is the components that are actually executing business processes. So moving work through the organization, routing work to different people, making sure that tasks are completed on time and so forth. And then on the right, you've got what they've labeled Business Modeler, which I would categorize as the design time components, right? These are the tools that typically business analysts and other business users would use to describe the business processes that they're looking to automate. So, and typically they would draw a flow chart. There'll be some kind of graphical modeling tool that allows you to draw a flow chart that depicts the steps in the business process, and who's responsible for each step, and so on and so forth. And the general idea was that you could model the process from end to end. And in some cases that was sufficient. You're just looking to do modeling, and then you print out these diagrams and stick them on the wall and stare at them for like 6 months. Or you can go on and actually automate those processes, hand those models over to the runtime site, and it would execute actual instances of those processes for you and move work through the organization. It's also interesting to me how much technology is around the outside of the BPM system, right? So we're looking at databases, often relational databases. So we're using Oracle or SQL Server or Postgres or whatever to store the information that is maintaining the state effectively of the system. We've got a document management system illustrated on the bottom here. Documents obviously very important to automated workflows. You need to be able to track all the documents that relate to a credit application or a loan application, whatever it may be. And then you've got all the internet infrastructure on the left here, the web servers and load balancing and clustering and so on and so forth. So these systems have been around in this way, as you can see, for quite a long time. They've been deployed very widely, and as many of you know, they're actually fairly good at what they do. You know, once they're set up and once you've got the workflows created, and you're able to move work through the organization, and they're a tremendous value to a business. We can, you know, save a tremendous amount of manual labor and effort because we're automating our business processes. So this was back in 2007, so around 13 years ago. So the question I asked myself then was, well, okay, what's changed? What's changed in the last 15 or so years? And how has that impacted this technology? And how is business process management technology today different from what it was back then? So I think the short answer is a lot, right? A lot has changed. There are many new technologies that are starting to impact this area of business automation. But in the 35 minutes that I have, I picked three that I think are perhaps the most significant. So the cloud, first of all, cloud computing has had a profound impact on business process management technology. We'll talk about exactly what that is. Artificial intelligence more recently has become very popular and is starting to have a tremendous impact also on the way that we think about business automation. And then finally, you know, almost no discussion of what's happening in BPM today would be complete, I think, without a discussion of robotic process automation, RPA, one of the hottest new technologies of the last 2 to 3 years or so. So first of all, the cloud. Cloud computing really wasn't a thing back in 2007, 10, 15 years ago. Certainly the internet was very prevalent, it was widely used, but the notion of offloading enterprise workloads into the cloud really hadn't taken off at that point. So these systems were not designed to run in the cloud. They were designed to be deployed in your data center on servers that your IT department is provisioning. There'll most likely be a whole rack of servers that are going to be hosting your BPM solution for your organization. The cloud has been driven mostly, initially at least, by economic benefits. You know, the key advantage to deploying the workload in the cloud has been the promise of cost savings. Not that they always materialize, but fundamentally the theory is that you can save significant amount of your IT budget by moving some of these workloads to the cloud. BPM in particular has some advantages that make it particularly suitable, I think, for cloud deployment, and it has to do with the idea that in the cloud you only pay for what you use. You're consuming compute resources as a utility. And when you think about it, a BPM system, even if it's heavily used and maybe running thousands of processes, typically a BPM system is doing nothing at all. It's waiting for something to happen. The processes that it's running are typically long-running processes that might take weeks to complete. So even if there are thousands of them active at any one time, in computer time terms, there's usually very little going on a BPM system. It's sitting there waiting for something to happen. So the notion that paying for usage it gives you a great advantage with BPM. It's very suitable because you're in theory going to cut down your costs very considerably by just paying for the time that you're actually using the system and not for the idle time. So economics, I think, drove the cloud to begin with. And a lot of good reasons why the companies were started to see the value there and start to think about moving their BPM and their workloads out onto the cloud. The other thing the cloud brought was accessibility. It made it much easier for users to be able to access these systems. Whether you're a business analyst looking to create a workflow, create a process model, or a user looking to interact with an operating process, the cloud makes it so much easier. Regardless of where you are geographically, you can get to those applications and use them without having to install anything on your local terminal and so forth. So there's considerable value there. But there are some significant implications of moving workloads to the cloud. Essentially, what we what we learned is that you can't just take a system that's running in your data center and plonk it in the cloud and expect it to work exactly the same way. The cloud really encourages new application architectures, new ways of putting together applications that work effectively and scale well in the cloud environment. And also as a result, it encourages new approaches to application development. There are new ways of creating these applications that involve different types of technology that are really necessary if you're going to take the full advantage of what the cloud has to offer. And so these two things combined have an impact on BPM, on BPM technology. If we take a look at, firstly, the architecture, the cloud encourages what we like to refer to as a microservices architecture. And in this diagram, the traditional business enterprise workloads of 15 years ago was what we might call a monolithic approach to an application architecture. It's typically a multi-tier system as shown on the left here. You've got a user interface, you've got business logic, you've got databases, and everything is bound together and deployed as a single unit. This is often what we refer to as a monolithic application. The downside of this type of approach is that these applications tend to be very large, very difficult to understand, and very difficult to change. You have to, any minor change requires you to redeploy the entire application, which can be a very significant process. The microservices approach really takes the approach that we're going to break down that application into smaller, more manageable services that are independently deployed. And each one can be modified independently of the others so that we can replace parts of this application at any one time. And we can also make in different groups, different departments within our organization responsible for individual microservices. So we can kind of democratize this application a little bit more in terms of how it's put together. Microservices are the de facto architecture now for cloud-based applications. It works extremely well in the cloud. We can deploy an app that consists of multiple microservices, and then each one can be scaled independently, maintained independently, and it makes optimum use of the resources we have in the cloud. So microservices architectures is one of the consequences of cloud computing. The other is the way that we approach application development, and kind of illustrated here again on the left, going back to 2000, 2005, early 2000s. How do we build these monolithic applications? Well, we had a team of developers in our IT department using development environments to write the code that became these monolithic applications. And this is obviously a very simplified perspective, but essentially this is how these applications have been put together almost since the inception of IT. What we're seeing today is a number of important changes, two of which are illustrated here. Because we tend to now build microservices-based applications rather than monolithic apps. We're using new technologies to do that, and a key technology that's fairly recently introduced is this notion of a container platform. That microservices are packaged into these modules called containers, which are then the units which get deployed into the cloud. A container platform is the underlying technology that's managing all these different containers and managing these microservices and allowing us to scale up and scale down and replace individual containers and so forth. Container technology is a very big thing for Red Hat. We're very active in that space. And we see that as the primary technology that's enabling the creation of these types of microservices-based applications in the cloud. The other interesting change is the lower part of the diagram, and in terms of who is now building applications. We're seeing a democratization of application development. It's no longer purely IT developers that are building applications for the cloud. It's possible now for business people to use tools that are relevant to them to also create microservices based on potentially models of the business, not necessarily code. So we're kind of changing the notion of what we believe source code is. It's no longer purely Java or C or C# code. It can be models of your business. That can be another way of thinking about source code that can ultimately be converted into a working microservice. So application development has been profoundly impacted by cloud technologies, and I think that the long-term impact here is this democratization of app dev and the ability of a much wider variety of users to be able to create applications. So going back to our BPM system, what does it mean? If we look at the 2007 diagram, there are clearly issues here with how we could put this in the cloud. I mean, in theory, you could take this entire application and dump it in the cloud, and it would kind of work. But we'd have a lot of problems with scalability. We wouldn't be able to change individual pieces. Like if I want to change the business rules engine, for example, or the process modeler, I can't do that without bringing the whole thing down and bringing it back up again. So it's very hard to re-architect this as a microservices-based application. And it's worth also pointing out there's a lot of code in a BPM system or a traditional BPM system that's related to functions that have nothing to do with BPM. You know, they quite often manage their own clustering, their own user management and authentication and authorization. There's a lot of basic capability that's coded into these systems and represents, in many cases, more than 50% of the total code that comprises that system. All of this can now be managed by the cloud. There's no need to include that in the application. So there's a lot of reasons here to think about, you know, how would we architect this now? How would we put this together for a cloud native world? And in trying to answer that question, I've looked to the open source community, which is very active in cloud computing. And I want to show you a illustration from a really interesting open source project. I pulled this directly from the project's website. This is a project called Cogito. It is an open source project that is looking to reimagine business process management systems for the cloud. And this illustration here kind of shows you where they're going. They've broken down that big monolithic BPM system into separate microservices that are communicating with each other using an open source messaging system called Kafka, a very widely used messaging solution now for cloud applications. And you can see that creating basically a loosely coupled arrangement of different services that can each be deployed separately and scaled independently for the cloud. On the right here, Kubernetes is the container platform. So I mentioned earlier that this container technology is really taking off in the cloud. Kubernetes is an open source container management solution started out at Google that's now become one of the de facto container platforms. And so building this on top of Kubernetes leverages all those capabilities. There's a lot more information on Cogito that I could give you, but in the interest of time, I just wanted to show you this one diagram that shows a little bit about how folks are reimagining the runtime side of the BPM system. So this is very much how you execute those business processes. When we think about the other part of that earlier diagram, the modeling side, the design time side, it's worth pointing out that BPM modeling tools fit extremely well in that illustration of how modern applications are developed. It's actually almost custom built for BPM, this notion that we could take the modeling tools that we've already been using in BPM systems and reimagine them in this new cloud native world as tools that create source code that can be converted into applications. And that's really illustrative of, I think, one of the other profound changes in BPM over the last few years is that BPM technology is repositioning as application development. Many of the vendors in this space are now positioning themselves as app dev companies. They're not so much business process management companies, but more where we're enabling a new range of developers, a new range of business people to be able to build applications using the tools that we've had for the last 20 years in the BPM system, but we're reimagining them in this way as app dev platforms for microservices. So really profound impacts, I think, in terms of how the cloud has changed the world of BPM. Um, the other two technologies that I want to talk about fairly briefly. Let's talk about artificial intelligence. I mean, that's something that's on everyone's mind right now. It's really risen to prominence in the last couple of years. Obviously, this technology is not new. It has also had a long history, but it's really the last couple of years that we've seen commercial interest on the scale that we're seeing now in artificial intelligence and machine learning in particular. Machine learning, as many of you know, is a way of automating decisions. So, and typically, the way that you deploy a machine learning solution is illustrated somewhat oversimplified here on this diagram, but think of it as a way of creating the business rules that govern how a decision is made automatically. So it's business rules that write themselves. That's often how I like to think about machine learning. The basic idea is that you start with a large amount of data, and in the business world, it can often be historical data. These are, for example, credit applications and the results of those credit applications, perhaps going back over the last 5 years. So if I'm a bank and I'm looking to automate how I decide how I decide on a credit application, whether I'm going to offer a loan or not, I would start with, say, 5 years worth of information, historical data. So these are the applications that we received, and these are the results of those applications. We put that through a model training process and create a predictive model. And that predictive model, there are multiple ways of creating those models, multiple formats, different neural networks and other types of formats. But fundamentally, you end up with a mechanism that you can now feed new data into that same model and have it make the decision based on what it learned from the training data. It's essentially, at a very high level, very straightforward. We're just simply perpetuating decisions, the methodology that we used to make decisions in the past, and when we're encapsulating that methodology, if you like, in a predictive model. On the right side, what we call model serving, that's the process by which we deploy a model and then run new data against it in order to make some kind of a decision. Obviously, way more complex than that, but that's at a very fundamental level what we're referring to with machine learning. I was thinking about, well, how does that affect BPM? How are we seeing this actually deployed in practice? And 3 use cases come to mind. What we call next best action, that's a technique where we're using a predictive model to inform a BPM system about what the next step in a process should be. So that's in itself quite a profound change from the BPM of 15 years ago, where the entire model was described in advance, so that every step was simply described by the model, moving to a more dynamic mode where we're making determinations about what the next step should be based on information that we have at the time. Machine learning is tremendously useful in that regard, because it can take the historical information logged by a BPM system as training data, so we can learn from what happened in the past when we got to this point in the process with this type of information, what typically was the next action taken, and use that basically to create a predictive model that says, well, in this case, it looks like you should do this next. And we're seeing that fairly commonly now, next best action as a use of machine learning techniques in business process management. The other area where I see it being deployed is task assignment, right? So one of the goals of a BPM system is to assign work to the right individual within an organization. When we have work that needs to be performed by a human rather than automatically, we're going to have to select from amongst a pool of resources who would be the best person to execute this particular task. There's various ways that we can use machine learning in that scenario to make that prediction, to decide based on the information that's coming in, and again on historical data, historical performance data, who would be the best person for that particular task. So I'm seeing predictive models beginning to be used in that way as a way of making better decisions about assigning work to individuals. But I think probably by far the primary use case that we're seeing is using machine learning to simply automate the business decisions that occur within the normal operation of a business process. So we're making a loan decision, and we want to decide whether we want to offer a loan to this applicant or not. That's something that BPM has been doing for many years, typically through the use of business rules engines. So typically, an analyst would specify the rules directly. These are the underwriting rules, or these are the rules that we use to determine who qualifies for credit. We're seeing increasing use now of machine learning to augment that process and to kind of mix the machine learning model with the business rules. And an important technique for doing that is DMN. I mentioned DMN earlier. DMN is a decision modeling language that now we're seeing quite a lot of uptake with, going beyond the old idea of business rules to a really graphical way of representing the rules behind making a decision, making an operational business decision. I don't have a lot of time to go through DMN in any detail, but the key thing I want to point out is that the DMN standard itself includes the ability to add a predictive model to a decision. So you can have a node within a DMN diagram here that actually references a machine learned predictive model. And so we can take the output of a machine learned model, mix that with business rules in order to come up with a final decision as part of the operation of a business process. By enshrining predictive models in a standard for making decisions, we're really seeing, again, new ways of leveraging this machine learning technology and increasing the amount of automation that we can apply to business decisions. And we can put that together with that same diagram and really think about that as another way of creating applications, right? So predictive models ultimately become microservices in our cloud. And really, it's just another route to building an application. And so, it's worth kind of thinking about all these different technologies as how they contribute ultimately to building applications that automate our business processes. Couple of very quick notes on AI, however. It is worth pointing out you do have to be careful with AI. It's not a magic bullet. Remember, predictive models are only as good as the training data. It's very hard to detect bias in that training data. If your training data is not sufficiently representative of the way that you make decisions, then the model itself will not be representative of the way you make decisions. And that can lead to all kinds of issues that are very hard to detect. Also, decisions made by predictive models are very hard to explain. There's a tremendous amount of research going on right now into how we can make predictive models explain how they got to a particular decision. But if you're making a credit decision, for example, typically a bank is required to be able to explain why they deny credit if they are unable to accept an application. A predictive model with the current technology, it's very hard to figure out why your credit application ended up in the deny bucket. Another good reason why you want to mix a predictive model with business rules so that you can see what rules are actually being applied in order to come up with an explanation. Finally, and very quickly, I mentioned robotic process automation, one of the really hottest new technologies of the last couple of years or so. We're seeing very widespread deployment of software robots. So RPA is essentially a technique that allows non-engineering, non-IT folks to create what are called software robots, which emulate human interaction with an IT system in order to automate typically very repetitive, labor-intensive work. So where folks, for example, might, as part of their regular job, need to, say, copy and paste information from one window to another, move information from a spreadsheet to a database, that kind of thing. The idea behind RPA is you can just train a robot to do that, and it will carry out that work automatically and relieve the human of all that repetitive labor. This area has exploded over the last couple of years. We're seeing thousands and thousands of robots being deployed across IT. Extremely popular, very high valuations on RPA companies. And clearly, immediate ROI, being able to automate human tasks saves you having to do that work, and then there's an immediate realization of ROI, and that really is what's driven RPA. RPA is complementary to BPM. The way I look at it, there are two ways of kind of interacting between RPA and BPM. Robots are very good at doing what otherwise would have been manual tasks. So the obvious way of utilizing RPA from a BPM perspective is simply to consider a robot as a resource that executes a task. And so we can route work to robots just as we would route work to people. In most BPM systems today have the ability to call out to an RPA system and invoke a robot to carry out a task. That's probably the most logical way of thinking about RPA in terms of in the context of BPM. There's also the aspect that RPA bots, as part of the work that they're doing, they may need to invoke a BPM process. They may need to kick off a process. So there's this notion that our RPA system can also call into the BPM solution in order to kick off a process, maybe process a loan application or whatever. They may be working on some task that perhaps is interacting with the user that ultimately results in new processes being set up on the BPM system. So typically you have this kind of two-way interaction. The BPM system can invoke robots and vice versa in order to more completely automate the business. And this really is the ultimate value of bringing these two technologies together, that we're able to increase the level of automation and do more of the business without necessarily human intervention. RPA also, there are some notes around things to be careful with around RPA. What we see with RPA, well, the benefits of RPA is that it's extremely easy to build a robot. Anyone can build a robot. That's also a disadvantage. It results in many robots suddenly being deployed around your IT environment. My general rule is think about RPA as a technology to automate human work. We see a lot of what I would call misuse of RPA, where it's being used simply to patch holes in IT systems. Generally, if there's a problem with accessing data from one system via another, that's not a task for a robot. That's something that you need to look at an integration solution to really approach fixing those holes. So one way of limiting the spread of these robots is to really think about them as useful primarily for automating human work. And remember that they're software, just like every other item of software. We're talking, a robot is an application. It needs to be governed like an application. It's no different. We still need version control, automated testing, and so forth, and beware also of the security implications of robots with very high levels of access to your enterprise data, simply operating on that data unattended. There are security attack surfaces that are exposed there. You need to be very aware of. So finally, RPA is another way of creating ultimately applications and kind of fits into this model. And this really is kind of the high level picture of where things have come from that earlier picture of the business process management system. Very much focused now on deploying microservices-based automation applications in the cloud, using all of these technologies. And if I had more time, we could add even more technologies to this list and look at how those have impacted business automation. But really, I think that the message is BPM itself is very much alive in this new world. And it's providing very much the key technology that both helps modeling and also on the back end the automation of those automated processes. Wanted to leave you very briefly with a little picture of where Red Hat fits into this. I've added here some of the Red Hat products that you can utilize to kind of start to build out this cloud-based business automation solution. Our cloud platform is called OpenShift. It's based on Kubernetes, the open source project, container management product. I mentioned Cogito there. I put the Cogito logo up there. That's not currently available as a product from Red Hat, but we're looking at that very closely as a next-gen business automation solution. And on the modeling side, we offer a product called a Decision Manager for decision modeling, which supports the DMN standard. Process Automation Manager is our business process management solution. Uses primarily BPMN, the business process modeling notation, the flow charting notation for business processes. And we have a very large number of products for developers, and I've highlighted one here, which is a cloud-based application development platform that runs entirely in the cloud, and an app dev solution for developers. We don't operate directly in machine learning or RPA, but we do maintain partnerships. We have an ecosystem of partners that we work very closely with there that help us put this whole picture together. So that's really where Red Hat stands, and I hope this has been interesting and useful, and that's our view on BPM today, and how far we've come in the last 15 or 20 years or so. So thank you very much. Thank you very much for listening. I'm very happy to take any questions that anyone may have right now.
Phil, thank you so much. That was terrific. What a masterclass on technologies and what's going on in the world of IBPM and technologies for IBPM. I know that you're looking there on, yeah, there you go. You got it. You got it, Phil.
Yeah, looking for the controls. Yeah. Yeah.
So terrific. So I'm going to ask the audience to keep providing questions as we go through our segment here. This can be both exciting and intimidating because there is just so much, and I know that there's so much depth to each one of these topics that you covered today, and there is just so much you can cover in the time that we have here, and you did a masterful job in providing the pros and cons of the different technologies. I want to ask you a very practical question. For an organization that's coming in and saying that, hey, I want to apply some of the latest technologies to my IBPM, not because it's a cool technology, it's because it can create a lot of value for my organization. If you put your practitioner's hat on, what has been your experience on the menu of technologies that are available right now? Which ones would you rank higher in creating the most value early on, and in companies that are just starting to adopt some of these technologies?
Yeah, in my experience, and speaking from the Red Hat's perspective, most of our customers begin this journey with the cloud. That's it's really about, and that benefits not just BPM, that benefits your whole IT infrastructure and all kinds of workloads. We focus on what we call a hybrid cloud at Red Hat, which is enabling you to take your IT workloads and deploy them in a public cloud like Amazon or Google, or in a private cloud in your own data center, and creating effectively one big giant computer out of all the computing resources that are available to you, whether they be on-premise or in the public cloud. And that's what we would call a hybrid cloud. And that gives you the flexibility then to decide where it's most cost effective to run each workload, and the ability to move workloads around from one location to another very easily. And it's the adoption of container technology and the container management platforms that really enable that. If you're using Kubernetes, the open source project, or OpenShift, Red Hat's enterprise version of Kubernetes, it creates a level playing field. It makes all these different cloud resources look the same. So I can move my workload from Google to Amazon to Azure at will, or I can bring it on premise. I can spike into the cloud if I have a sudden increase in workload. I can move some of that into cloud-based resources temporarily. That's kind of the foundation on which a modern IT environment is built. And then you can kind of move on to think about BPM specifically, and a cloud native way of automating your business and business processes. And all these technologies I talked about ultimately can be deployed in that way and on those modern container-based platforms. So that's where it starts. It starts, I think, with clouds and containers, and then you then have the basis on which you can kind of move forward with other types of workloads.
Terrific, terrific. I'm gonna pick up on some questions here that the audience is sending our way, and keep sending those questions, because I'm seeing them, and I'll capture as many of them as possible in our allotted time here. There is a Gopalakrishnan is asking about how does a process discovery tool like Celonis, and I'm not sure if you're familiar with Celonis or not, but Celonis is the tool that he talks about. How do process discovery tools fit into the framework you shared, and whether they use machine learning for next best action?
Yeah, we didn't talk about process mining or process discovery. I would broadly lump them into the category of modeling tools, right? So a modeling tool is something you use to create a model that can then be automated. So a model of a business process or a business decision. That tool can be something that simply allows a user to directly specify what that model is, or it can be an analytical tool that's looking at your enterprise data and the logs from all your various systems and kind of inferring automatically what your business processes are. And that's the whole area of process mining, being able to automatically derive models of business processes that you didn't even realize you had, based on essentially the logs of your enterprise IT systems, and looking at what they're doing and in what sequence, and inferring what your processes must be. So it's another way of creating a model. And it fits into that category of modeling tools. If you think about that being the broadest possible based interpretation of modeling tools, are tools that you either have people creating models or that are using AI, as in the case of some process mining tools, to build those models. So on my diagram, that's where I would fit that technology. I would fit it in the modeling tools section. And it's a very exciting new technology that again promises to enable us to automate more of our business, because we're able to discover processes we didn't really know we had in the first place. So it fits a very important use case, I think, and that's how I would view that type of technology.
Very good, very good. I think we have time for maybe one more question here. So the one that's coming up, it's about low-code platforms. What about those low-code platforms? How do they fit in the picture with RPA, BPM? How does that play out?
Very good question, and that would have been my fourth bullet point. If I'd had the time to do 4 technologies, low-code would have been next on the list. So low-code technologies were designed essentially for business people, right? They're designed for non-traditional programmers to create applications, and so they kind of fit alongside these other technologies. It's another way of building an application. The thing about low code is we do have to be a little bit careful there in terms of how we use that. It's a little bit like RPA in the sense that you can get uncontrolled creation of these apps, and you end up with applications deployed all over your infrastructure that you don't really have proper governance and control over. The one thing I would say about low code today is that it does tend to operate in a little bit of a silo. It's great for business people who want to create apps very quickly, but it doesn't interact with the other participants in the application development process. So IT generally is in a separate silo, and so we're now having different silos of application development within our organization. What we're trying to get to in our view of the world is bringing everyone together at this central point, at this container point, so that we're using the same governance mechanisms across all these different approaches to application development. So low code is absolutely, again, it's a hot technology. It produces an ROI very quickly. it's very like RPA, and that there are certain caveats. You have to be kind of careful about how it's deployed and how you govern the applications that are produced by low code, but very relevant nonetheless.
Phil, thank you again for a masterclass on all these technologies and how they work with iBPM. Very grateful to have you here. Thank you for sharing your wisdom with us today.
Thank you. Thank you for the opportunity.
All right, ladies and gentlemen, this completes our session, and I ask you that as you close the session, there will be you can click on the pop-up to fill out a short survey and provide feedback on what your experience has been. And I hope to see you at the top of the hour, because we have a very special session with Oliver Michael, who is the partner and vice president at Siemens, and he's going to share with us how they sped up their proposal phases by 300%. Using an intelligent tender document screening approach. And so how iBPM works with some of their critical business processes and automation, and from a true practitioner and a great global organization. So look forward to seeing you at the top of the hour, and I'll close the session now. Thank you.